Good afternoon, everybody. Welcome to our webinar for this week. I'll just give it a couple of minutes to see if anybody else is joining, and then I will hand you over to our speaker. Okay, we've got a few participants now, so I think we'll make a start. So it falls to me the privilege to introduce our newly elected and anointed chair of the Ground Source Heat Pump Association, Laura Bishop. So without any further ado, I'll hand over to Laura. I'll be taking the questions in the chat, so please put the questions in the chat as you go along, and I will do my best to make sure they're all answered at the end. Over to you, Laura.
Thank you, Chris, and thank you for the intro. Yeah, that just happened yesterday, so still very fresh, but really, really exciting to be in the chair for the association for the next couple of years, and we have so many plans, and it's a very, very exciting time in the industry. So yeah, watch this space for what's going to be happening next. So just on that, actually, next week is half term for most people in the UK, I think. So we're having a break next week, but then we are starting again the week after in November, and we have a new program coming up where we're going to be covering some new topics. We're going to have a series on open loop system design and construction, which will be really, really useful. So Chris will be presenting during that, and John Findlay and others. We're going to be having some pieces on education and training, which is one of the big areas that the Ground Source Heat Pump Association are going to be focusing on. That's such an important piece of work, with especially with young people, people looking to possibly retrain to get into the industry, because we need more people if this industry is going to grow. And we're going to be looking as well at some regulations in the drilling industry, and there's a lot more coming up with some really good guest speakers as well. So today I'm going to be talking about heat pumps in retrofit situations, which is an area that I seem to specialise in, which hasn't really been what I've intended to do, but it is a really, really interesting area. So because I regularly come across people who say you cannot put a heat pump into an old building, and various variations on themes like that, I thought this might be a good presentation to put together. There's going to be a lot covered. Obviously, we've only got about half an hour, so I am going to skim over some bits. So I'll be very happy to take questions at the end, as Chris says it. And if anybody's got any other questions afterwards, we do have the GSHPA email, the help email at the end, so you can send them through if you've got any other questions or comments. So to start with a bit of background about old buildings, and when I'm talking about old buildings, I'm talking like I'm talking about basically any buildings up to around 2010. So in the UK, obviously, we've been building buildings for more than 1,000, 2,000 years. And some of those buildings are still with us now. People are living in houses that date back to the 16th century, some of them before. A lot of houses dating back to sort of the 1800s, 1900s and early 2000s. And they will be with us for years to come. I don't know what the statistic is for what proportion of existing buildings will still be here in 50 years, but it's a high proportion. And we do know that obviously new builds, as of those that are being built now, have much improved building regulations and building standards to what we have seen in the past. So what do we do? Do we ignore all the existing buildings, all the ones, say, pre-2000, and say, well, they're old buildings, we can't put heat pumps in, they're too leaky, the heat losses are too high, it costs too much to retrofit everything? Or do we say they cannot use heat pumps? Do we say, well, they could continue to use gas and then switch over to hydrogen, but we know that hydrogen is around 10 years away before it's widely available to people, at least. And if we're going to hit net carbon zero targets, we probably can't afford to wait that long. This is a little picture of a street round the corner from me, and this is typical of houses, streets all over the UK. I think you've got early Victorian terraced houses there. Just beyond, you've got sort of mid to late Victorian villas. You've got 1940s semi-detached houses. You've got just around the corner a brand new housing estate of about 10 houses. So I'm sure we can all think of streets local to us where we have a real mix of houses of all different ages. And the question is, can they have heat pump fitted, an air source heat pump, a ground source heat pump, a communal heat pump system, or not? And not just obviously housing, but commercial buildings as well. And there's a little graph that I found. It's dating back to 2015, this graph, but it basically shows that in the UK, or sorry, in England, Wales, nearly 5 million of our homes were built before 1900. Actually, I just can't see the minimize that. Sorry. And then on the right hand side, you can see the sort of, we've got less than 1 million houses that were built between 2010 and 2015. So the big proportion of houses, that there is a big proportion of houses that are pre 1900, and there's a huge proportion that are built before 2000. So what do we do with all these houses, not to mention all the commercial buildings and community buildings and industrial buildings in the UK? So, a bit more background. We know that current new builds are built to modern building regs with very high standards of fabric and air tightness, and new builds, as in the ones that we're building today and will be building in the near future, we have the future home standards, we have maximum flow temperatures from any kind of heat system being set to 55 degrees C, whether that's a gas boiler or a heat pump. And they have super low heat demand and still obviously hot water demand. But we also have a cooling demand, and I'm seeing more and more houses coming through now that where there's a cooling demand. And if you've got a commercial building, the chances are you'll need cooling anyway. But the great thing about new houses and new buildings is that they are heat pump ready. So if you wanted to put a heat pump in, you could do that with no concerns over getting heat out or getting cooling out, keeping the building warm and making enough hot water. And for new builds, I don't think there's any excuse for not putting a heat pump in. It's actually, for me and for many of us, it's the most sensible way of producing low to zero carbon heat and cooling if you need cooling as well. But then we have the old buildings, old being sort of pre-2000 and older, the 1900s houses, 1800s houses. We could be looking at high temperatures from boilers, so H271 is the typical gas boiler flow temperatures that we still see now. Potentially we have small rads, we have leaky windows and roofs where there's poor building fabric, or you know, they're older, so they've got like leaks, actual cracks in between windows and things like that, where heat is being lost. Potentially small diameter pipework, uninsulated pipework, so you get heat loss where you don't want it, which means you are removing heat from where you do want it. Pumps may not be variable speed, or they may be set to specific flow rates or specific temperature differences, and we also have to consider hot water storage and low temperatures. So this is where the sort of the myths start to creep in, and I regularly hear people from other areas saying that because of these reasons heat pumps are not going to work. They're great, heat pumps are brilliant, but they can't work because of this and this and this. So the following few slides are just really going into some case studies and some projects that I've been involved with over the last 6 years, because I just want to show how we can turn this around. And I'm not going to say that 100% of buildings are suitable for heat pumps, that's certainly not the case, but just because of these reasons listed here, it does not mean that a heat pump cannot be retrofitted into an existing and older building. And the point is that while people are talking and saying this can't happen, it is actually happening. It is. So we have, over the last 6.5 years, I've been running my business, and lots of other people who have been working on ground source heat pumps long before I started. We know that this is happening in leisure centres, council offices, schools, colleges, offices, universities, hospitals, mixed-use developments. People are putting heat pumps in, and these are buildings that were built maybe 20, 30, 40 years ago, and they are working well with heat pumps. And of course, we've got individual homes. This is becoming more popular now because people are looking at the climate agenda. They're concerned for the environment. They're concerned about air quality. So people are now looking more and more, and not just looking, sorry, they are installing heat pumps. They're just doing it. And social housing in Derby, Derby Homes, which is part of Derby City Council, whenever a gas boiler comes up for renewal, they are, on the whole, they're putting air source heat pumps in instead of gas boilers, sometimes with some retrofits to the internals and sometimes without. So this is actually happening, and while we're all having these conversations about can it work, can it not work, people are doing it. So here we go. If you have an old building, what is the best approach? Because you can't treat it like a new build, you absolutely can't, and I'm not even going to try and say that it's that easy, it isn't. So I found a picture of a very old building, and I think I wouldn't put a heat pump in here. There might be some other improvements you might need for the building up there on the right hand side. But the biggest thing I have to say about looking at older buildings is you need to take a holistic approach. You cannot just walk into a plant room and say, right, here's a gas boiler, let's take it out and put a heat pump in of the same size. If you do that, you're just not going to succeed with your project. So the first and biggest thing to think about is it needs to be a holistic approach, which means looking at everything. And keeping an open mind as well. This is a really important thing, because people might go into an old building and say, we're just going to stick a heat pump in, we're just going to do it. But actually, when you go into a building, you start looking at it, you could say, actually, in this case, a heat pump wouldn't work for you for these different reasons, or a biomass boiler might be better, or you might be better staying as you are, or you might want to look at a hybrid system with maybe gas boilers and a heat pump. So it's really good to keep an open mind when you first start to look at an existing building, and to treat the building as a whole. So this goes back to the holistic approach. It's not just the heating plant, the boiler or the chiller, it's the heat distribution system, it's the heat emitters, whether that's radiators or air handlers or underfloor heating. So have a look at the whole thing, and to treat every building individually. So just because a solution has worked for an existing office block down in Exeter, for example, it may not be a cut and paste and do it again up at a similar office block in Aberdeen or in Oxford or Cardiff. You may be able to lift the majority of a design from another similar building and apply it to another building, but you must treat each building as an individual, because each one will have its own little things that you need to find out about and address. So every building is unique and individual. And another big thing, because when actually, if you go back to fundamentals, what we're trying to do here is to keep the occupants of the buildings warm or cool, or give them enough hot water so they can work and live comfortably. That's all we're trying to do here. So talk to the occupants, say, you know, are you cold, are you hot, are you comfortable? Any comments about, you know, is there sufficient hot water, things like that. And it'll be amazing the different people that you talk to who give you a real indication of how the building is operating, because as I say, what we're trying to do is to make people comfortable in their work and home place. Be prepared to change your operating regime. It's very often in the UK and probably other countries as well. People tend to have their gas boiler come on at 6 o'clock in the morning, get up, get ready for work, and then it goes off again at 8 o'clock. And the building cools down, and then it's about 4:30, the boiler comes on again, heats the building up very quickly till maybe 9 o'clock. People are starting to go to bed, and then the boiler goes off, heating goes off, so the building cools down. You may want to think about changing your operating regime from that if you're going to be using a lower temperature heat system. So that's another thing to think about. So you can see it's like a whole building, whole operating philosophy that we're trying to achieve here. And it might sound like a lot of work, but if you're talking to somebody who knows what they're doing, it's not an awful lot of work. This is their job, so they're used to dealing with older buildings, and time spent upfront understanding the way the building operates and trying to address any existing issues, as well as looking at a low carbon system, will probably pay off financially in the long run anyway. So it's always good to spend some time, and I've talked about previously on the importance of design and getting things sorted out early before you start on site before. Okay, so some examples here. Let's go into have a look at some buildings. This is a large public school down in London. They are on the gas main, so they're using natural gas to produce all their heating and hot water. There's dormitories on site. There is a selection of buildings of various ages dating back to the early 1800s when the original school was built. And then over time, they've built more and more buildings right up to one that was built only about 3 years ago, underfloor heating and heat recovery and all kinds of things like that. And everything in between. I think there's about 12 or 13 buildings on the site, and we're looking at putting in a centralised heat pump system with a low temperature heat network. Sorry, to me it's medium temperature because it's going to be running at about 65 degrees C, the heat network. But I spent 3 days on site going round the buildings. This is after I'd done the plant room surveys, because I wanted to see how they were heating their building, and I wanted to have a chat to anybody who was actually in the building, teachers, cleaners, people like that. And some of the things I found were really interesting, and you will find this in buildings all over the UK. The photo there on the top left is my favourite photo, because this is the middle of January, about 7:30 at night. Radiator in a corridor, there's radiators all the way down this corridor, single glazed windows open, and if you looked down the corridor, every window was open and the radiators were on, but not very high. So, I mean, I know January this year wasn't the coldest on record, but the fact is that here we have a prime example of an existing building that's getting too hot. It's just simply too hot. Talking to the teachers as well, if you look on the bottom right here, we've got a classroom refurbished. This is the oldest building on the site. We've got nice new radiators, again, windows open, because the kids have been in there all day. It's become very hot. And talking to the teachers who are still in the staff room, different parts of the building, all saying building's far too hot. I never hear that. People are always complaining it's too cold, even with a gas boiler operating. But in this particular building, they're saying it's far too hot, and that comes down to building fabric and controls, which, you know, in older buildings is more difficult to control. But the positive from a heat pump system is, straight away I'm thinking building's too hot already, and not just one building but most of them on site. So therefore, if we were to put in a heat pump that was working at 60 degrees, for example, the chances are that even in the middle of winter, they're still going to have sufficient heat, and it's still going to be, in fact, probably a more comfortable environment. Now, I'm glossing over a lot of all the other work that went on into this, but by going into the building and looking, you can understand a lot about the temperatures that are being achieved and what needs to be done, whether a heat pump might work in here or not. The other couple of photos are teacher's desk here, sitting next to a big radiator, still got an electric fan heater. Something's clearly wrong in this room. There could be other things at play here. This radiator might be broken. There may not be enough heat coming through it, but for whatever reason, they need an extra fan heater because it's cold. And this one here, it's like play spot the radiator. So you've got single glazed windows at the back, single panel rad, TRV on it just there, but most of the heat is being blocked because of this desk. And the reason I showed that is just because people are still in this room saying, be warm enough, no problem, but you've got radiators there that can barely emit the heat that they are producing. So all of these are making me think, as I'm walking around, I think a lower temperature heat system could still work quite well here. And as I say, I'm glossing over a lot of the other work that's been done, sort of a lot of the calculations that have been done as well. Another example you might find in a commercial building is swimming pools. So I do a lot of work on leisure centres and heat pumps for leisure centres, especially where councils want to decarbonise, and that's their big driver. So this is a particular heat exchanger that I spotted when I was doing a survey of a swimming pool in Cambridgeshire. I wanted to, these guys were using gas boilers running at 80 degrees C. So as soon as I got back to the office, got onto Certikin, who are the manufacturers of this heat exchanger, sent me an email saying, right, here's a serial number of your heat exchanger. I want to put 45 degrees C from a heat pump into this. Can I do that with this heat exchanger? And if not, what can I do instead? And they came back very quickly, gave me a new model of heat exchanger that will take that, well, it's actually, I think, 50 degrees C, and produce the same kilowatt output and the sufficient temperature required to keep the pool up to temperature. That's something that can be done very, very simply. And it's just asking the manufacturers, how do we adjust this system to make it work with a lower flow temperature? Now, there is a cost obviously associated with replacing a heat exchanger, but the fact that you can then install a lower temperature standard heat pump with a higher efficiency because it's running at a low temperature would, over time, over a short period of time, overcome any costs associated with replacing equipment like this. So just because you have a heat exchanger in place, I mean, this is a very small exchanger, does not mean that it prevents you from replacing the equipment fairly cheaply. If you're looking at a big project, and this is probably just a very small percentage of the cost to do this. And then other examples you'll find in commercial buildings which need to be considered. This is why I'm saying it's a holistic approach. You could have hot water generated in an instantaneous plate heat exchanger. You can have hot water made in a calorifier. And the reason I've included this photograph in the middle is because this calorifier is about 25 years old. If you zoomed in or walked up close to it, you'd see it's in a really poor state of repair, lots of corrosion, some leaks on the floor. If you're putting in a heat pump system, it might be a good time to look at replacing other equipment that's at the end of its life. So for example, in this one, this is a council head office also in Cambridgeshire actually. Part of the works will be to replace hot water cylinders, and then we have a great opportunity to make sure that we can match that against a lower flow temperature. I'm not going to touch on Legionella today because that's such a huge area on its own, but it's certainly something that we always take into account because I don't want to be responsible for people coming to harm because of Legionella problems. But again, just on the hot water heat exchanger here, and also on the air handler, getting in touch with Stockfish, getting in touch with the air handler manufacturer and talking to them, very quick conversation, few emails. This is how it's working at the moment. This is how I want it to work. These are the new design conditions. What do I need to do? On the air handler, the cost of replacing the heater battery with a different battery was about £800. Plus, obviously, you've got to fit it. But it's not mega bucks to do this kind of thing. So just because you've got an air handler, just because you've got a heat exchanger does not mean that you cannot replace equipment and make it work with a lower temperature heat pump. The other thing just to say about the heat exchanger here was that had been massively oversized, 420 kilowatts for 8 showers. We are able to replace that with a more suitably sized heat exchanger, saving them space and just delivering exactly what they need for those showers. And this is a case study that, should we check the time actually? Yeah, okay. So this is a case study done in 2016. Actually, this was installed in 2016 with Shark Energy Systems. This is Scottish Borders College up in Galashiels. First sewage heat recovery system in the UK using heat pumps. And this was about 18 months in development. It's a college campus, as you can see at the top right there. We have, again, a variety of buildings. We have the High Mill, which is this building in the middle, dating back to the 1800s. Very thick walls. It does have double glazing now, but it's an old building. And then a variety of different kinds of different ages of buildings as well. And we put in 800 kilowatts of water source heat pump connected to a new heat network, serving 5 separate gas-fired plant rooms on site. And this has been running since 2016. It's a bit of a showcase project. These are some of the photos I took on the site survey in 2014. So you can see we've got radiators, we've got air handlers, We've got all sorts of different emitter systems, and this at the bottom here is the energy centre. We had an energy centre built with the heat pumps and the sewage heat exchanges in there. I think there's some points here. Yeah, so the point I just want to make here is this has been running since 2016 and the college are extremely happy with it. We didn't change any heat emitters in this building or in the buildings at all. We talked to the college and they were extremely amenable. First of all, they were very happy. The thermal comfort was absolutely fine to start with. We worked very closely with them, and what we said to them was, we will run the heat pump, and first of all, we will find out whether people complain that they're cold, and in which case we could maybe change out a few radiators where there's specific problems, rather than just doing a blanket. Every radiator's got to be changed. We'll also run the heat pumps for longer, so they come on a bit earlier in the morning, and they might run at a very low background rate during the day and then go off a bit later at night, so that the building does not have a chance to cool, heat up, cool down, heat up, which is not good for the building fabric anyway. And that certainly worked well. There was one air handler in the kitchen area that had to have some work done on it, but apart from that, no other changes have been made. The second thing to mention about this, and I'll talk about this on the next slide, is that they kept all their gas boilers in plant rooms as backup, and each plant room was designed so that you could have gas boilers coming on in one plant room, but not in the other plant rooms, depending on what the heat demand was in a specific area. So there's 3-port and 2-port control valves in each plant room, enabling the heat network to be either switched off to that plant room or not. And the good thing about that is, as to talk about hybrid or bivalent systems, if you have very, very cold weather, your control system can look at the weather or look at the temperature and say, right, today it's too cold for the heat pump to run, turn it off, and we'll turn all the gas boilers on. And then the next night, the control system looks again and says, actually, it's warmed up a bit, so let's put the heat pumps on. And you could find then that your heat pumps are actually able to do 97, 98% of your annual heat demand. And maybe your gas boilers just need to kick in for that 1 or 2% of the year when it's -10 outside, which these days doesn't happen very often. But those are the sort of options, and those are the sort of holistic building-wide measures that we need to look at when you are, these are the sorts of things that we need to get into place when you're looking at older buildings and retrofitting heat pumps. But this is a clear proof, and there's loads and loads of other case studies, not just from me, but from many, many people in the industry who have got case studies such as this, where heat pumps are working in all buildings, and the people living and working there are very pleased. So just the last slide here, other considerations that you might want to think about, or if you've got somebody coming in to do a survey, these are the things I'll be looking at. Is there space for a heat pump? Where is the heat pump going to go? Do you want to strip out an existing plant room and replace your plant with a heat pump? Do you want a separate energy centre or packaged plant room somewhere and keep your plant as backup? I mean, sometimes that's a really good practical way to work, especially in the early days, because at least you do have that gas boiler there as backup if you need it. At Borders College, they found they didn't need them. And other places I've worked as well, they found that they were worried and kept the gas, thinking they probably would run it, a month a year during December or January, and actually they've never run the gas boilers. So just an indication of actually that by running them longer, and also heat, sometimes emitters are slightly oversized, mainly due to maybe fabric upgrades, and the heat pumps can cope perfectly well. We have to remember that we are not stuck with heat pumps that only operate at 45 or 50 degrees C. In the not so distant past, we were all using things like R134A refrigerant, which can really only do about 60 degrees C, depending on the incoming brine or primary temperature. Now we've got access to ammonia heat pumps, which can do 90 degrees C flow. We've got propane, isobutane, other natural refrigerants, carbon dioxide, if the design conditions are right. So you're not automatically heat pumps low temperature. It's not an automatic thing. There are a lot of options out there. Obviously, the lower the temperature, the higher the efficiency of the system, but you do have options for higher temperatures if you really need them. And I'm working on a school at the moment where we are looking at 70 degrees C flow into a new heat network to serve 12 plant rooms, which are all on oil at the moment. So that's perfectly feasible as well. And it all those costs, running costs, capital costs, savings, they all have to be wrapped into a financial model early on. I'd always recommend putting metering in, because that gives you a really good indication of whether the system is working as you had planned. So electricity meters, heat meters, you can then compare, you know, what's your efficiency. You can compare that against the outside temperature. You can compare what temperatures you're achieving internally as well in the rooms, which is the important thing. That's what we're trying to do. And which brings me to my last point, which is after you've installed the system, talk to the occupants, find out what they think. Some of them won't even notice that there's been a difference. That's what we've actually found, that people are like, oh, you put a heat pump in, okay, or you've reduced the flow temperature, no idea, just still going to work, still feeling the same as they did before. But it's really important to review that. And if you've got somebody on board with you, somebody who is, I'm talking about like a client or a building owner who's then got somebody with them who's developed the system, it's really good to keep that relationship going, because you can review that together and make any tweaks to the system. And I think that's really all I had to say. It was a real whiz through, as these always are. Hopefully that's given, I really just wanted to give some confidence out that retrofitting heat pumps into older buildings is not a big deal. It's perfectly doable, and these are the sort of things that need to be thought about. So if people are listening and they've got older buildings that think, yeah, I could actually put a heat pump in now, then we'd be happy to talk to you about that. But I'm certainly willing and happy to take any questions or any comments. No, that'd be great. Thanks, Chris.
Thank you, Laura. Thank you very much. Yeah, it was very interesting. We've got one question from Gilbert. He's talking about the Borders College project. And could you give us a little bit more details about the source? So was it groundwater or just the sewer water? And what effect did that have on the temperature of that water?
Yeah, so yeah, this was a sewage water project. So we were lucky in that there was a sewer running actually probably only about 40 metres to the right hand side of the energy centre. So just in that bottom photo, it's just over here somewhere on the right. It was a mixed sewer, which means it's foul and got rainwater in it as well, which dilutes the foul water. But for RHI purposes at the time, we had to use a combined sewer. Temperatures within sewers tend to range from anywhere between 8 and 20 degrees C. So because people are running their showers, their baths, all of that's going into the sewer, and industrial processes and things like that. So it's a really good, widely available, higher temperature primary heat source. It's more difficult to deal with because obviously you have a lot of solids and things that are in the sewage that you have to filter out. But that again, you know, the Shark equipment, it's a Canadian company. They have a lot of these systems running in Canada. So the equipment is available for filtration of that. But the upshot is that you end up with a efficient system because you've got a higher incoming temperature most of the year.
Fantastic. I was just trying to see if are there any other questions, because Gilbert was the only one who came in with something.
Hi, I have a question.
Okay, Chris, thanks.
Sorry, am I not interrupting anybody?
No, not at all. No, please.
Oh, thanks. We're getting a lot of inquiries for air source heat pumps in domestic houses. And I think a lot of it's because of this Green Homes grant, or definitely so. But we're going out to sort of literally, possibly 100 of these houses, and most of them have got, virtually no insulation. They might have a bit in the loft, or they may have double glazing, but they're sort of solid walls, and it seems really difficult to be able to sort of restructure the house to form the insulation on the walls. Is it still viable for them to have an air source heat pump?
It is, but you need to consider everything else within the fabric and within the house, as you've just said. So I live in a 1970s house. We do have cavity wall and we've got double glazing, but it's not an amazingly efficient house. We're having an air source heat pump fitted next year. But the way I will do that is to run the heat pump. As I was saying, I'd run it for longer. So you might want that heat pump to be on a setback temperature all the time, so that the building never goes cold. That's the key to it, because what you don't want is the building to cool down to very cold, and then the heat pump takes ages to bring it up to temperature, and then the homeowner is upset because the house is cold. You may also want to look at spot changing specific radiators that are particularly smaller, if they're single panel or something like that. But just because it's single wall or solid wall, sorry, does not exclude it from having a heat pump at all. But you may want to look at running the heat pump for a bit longer to keep the temperature inside the house.
I can't.
So in your experience, you know, they may.
Go on, Chris. Sorry.
Sorry, they may have quite a new, you know, quite a high efficient condensing gas boiler in there. You know, I know ideally we'd like to get rid of the gas boiler, but you know, particularly with older people, you know, they're on a budget. They are struggling to pay their bills. I feel that sometimes you know, I might be getting them financially to do the wrong thing. You know, I know that you know, we want to get rid of the carbon, and I know the way we're all going. But on the other hand, I do feel for these older people that haven't got the money to spend on their fuel.
I think you know, one of the things I haven't talked about at all here is finance. But very early on, you should be looking at, okay, so how much is it costing you right now to run your oil-fired system? How much will it cost you to install and run an air source heat pump? And it might be that actually the air source heat pump is going to cost them 3 times what it's costing them on oil. But you know, hybrid systems could come in that case. You could have an air source running for from March to October or something, and then the boiler is just there for the very cold months. That's one option. Or the finances early on will tell you actually whether this is a completely dead in the water, don't even do it. But from a carbon point of view, it's the right thing to do. But from a financial point of view, you can only see that by doing the calculations.
Okay, thank you.
I think one of the key things we're working on with the association at the moment is the disparity between gas and electricity prices, working on it from a policy point of view. And we're really seeing some willingness now in government to address that disparity. And that should bring some of these projects into financial viability, for perhaps currently they're not. So that's very important. Okay, thanks, Chris. That's really, really useful. A question from Nick Remington. Do feasibility studies include the impact to the electrical infrastructure / spark gap, which we've just discussed? He's personally come across issues getting reinforcement to large heritage sites. Is that something that you've come across, Laura?
Yes, absolutely. And it's a good point, and it's one that should absolutely come out of feasibility stage, because you don't want to be getting into detailed design and find that you can't get an electrical connection there. It's really interesting, actually. I'm working on a very big historic site in Oxford, and they're having problems getting sufficient electrical capacity to the site. So what they've decided to do, because this is another big holistic project, not just about heat, it's about power as well. They're actually having a big solar farm built nearby, and with clever thermal storage and batteries, they're actually looking to just connect the heat pumps, and this is 400 kilowatts of heat pumps, so it's not a small system, directly to the solar PV, and running it directly off that with thermal storage and batteries. So that's an option. But you're right, you know, if there is no planned electrical upgrade in the area, that is a big stopping point. So it's something you need to identify early on. There are ways to get around it, but you're right, Chris. I don't know if you've got anything else you want to add to that.
No, Bean's just made the point. So Bean Beanland, our outgoing chair. Thank you, Bean, for 2 years of fantastic leadership. Bean just makes the point that upgrades to supply have been very costly historically, but the heat pump industry is engaging with the network providers and Ofgem to try and do something about that. So longer term, we're hoping that those infrastructure upgrades will be more sensibly priced. Okay, another question from Bean, and I suspect Bean's asking the question for the benefit of others here, but can heat pumps in retrofit make use of time of use tariffs?
Oh, yes. Oh, one of my favourite topics. Absolutely. So time of use tariffs, for those who are not aware of them, most people will be aware of economy 7, so cheap electricity at night, expensive electricity in the daytime. So that could mean in a heat pump world that you run your heat pump during the night, you fill up a big tank of water, and then you run your house or your building off a big tank of water during the day and the heat pump doesn't operate. That's the ideal. Thermal storage actually ends up becoming very, very big, which in some cases is fine if you've got the space, but not in other places. People like Octopus Energy and Good Energy are bringing out agile electricity tariffs, which are based, instead of being night and day, they are based on half-hourly periods. So if you've got your heat pump connected to the internet and connected to a smart tariff, your heat pump could be switching on and off without you even realizing it, to take advantage of cheaper electricity. That tends to happen when there's a lot of electricity swimming around on the grid, and people, the national grid, need to get rid of it because they can't balance the grid. Heat pumps are a great way of doing that because they can switch on and fill up a tank of water. Alternatively, they could be running off a battery, so the electricity goes into the battery and then runs the heat pump at another time. So absolutely, I mean, electric heating generally, that's why it's so flexible, because they can make use of these more flexible electricity tariffs, which A, saves you money, and B, helps to balance out the national grid. So when you've got lots of wind and lots of PV coming in, helps to balance that out.
And that's one of the key advantages, technical advantages of ground source over air source, is that it has effectively the same efficiency night or day. So if we've got a windy night, then the ground source heat pumps can be running at the same efficiency, whereas an air source heat pump perhaps would be at a lower efficiency during that point.
Absolutely.
Bean makes a supplemental point on the electric infrastructure. There's a big deployment of electric vehicles at the moment, which is gathering momentum every day. And we can actually piggyback on that as a heat pump industry to deliver projects where perhaps we wouldn't have been able to before. Okay, really nice question from Nick Remington. What is the association's opinion of ambient loops for residential developments?
Yes, they are. Well, I'm a big fan of them. They're particularly good though if you have a cooling demand as well, because your houses or your businesses that might also be attached there can take cooling and heating off the same network, which is brilliant. Yeah, I mean, the thing with ambient loops is that each house has its own ground source heat pump, which takes up the ambient loop. So it does free up, it does provide a bit more flexibility, because each heat pump will just do what that particular house needs. You know, there might be 50% of the heat pumps off, 50% of them working, and each person has control over their own heat coming in. In terms of efficiencies, it can actually be, well, I don't actually think there's a lot of difference in efficiency. I've done some calculations, but not recently, on the differences between central plant delivering into a fourth generation network versus not centralized plant delivering into an ambient loop with decentralized heat pumps. Either works well, but there will be differences as to which is most applicable to your site. But I am personally a fan of ambient loops, fifth generation. Yeah, so Chris, have you got anything else you want to add on that?
Well, I'm a big fan of those because I spend most of my time designing them. Pays the mortgage. So yeah, I love them. I think they're absolutely fantastic. You've got so many advantages. One that I would highlight is that you can select your heat pump for each individual building on that network. So you may have to go to a high temperature product in one building, whereas in all the others, you can run it with a lower temperature product. So that's one advantage. And I think one of the advantages that's often missed for ambient networks with distributed heat pumps is that those heat pumps will only be running at domestic hot water temperatures when they need to run at domestic hot water temperatures. Whereas if you've got a central plant solution, unless you put in two pairs of pipes, one for domestic hot water and one for space heating, you're stuck at that higher temperature in most cases. So there are some fantastic opportunities out there to look at these networks. I would just emphasize that these things need to be designed properly. And it is very important that you've got a really good understanding of ground loop design before you embark upon getting into these ambient networks. One of the things that we do as a company is we have no central pumping on those networks because that avoids central costs for, say, the housing association, which owns the houses. But don't do that without a safety net if you've not been involved in ground loop design for a while. Okay, fantastic. So Nick's asked me to get in touch with him after this, so that's fantastic. I'm more than happy to do that. So from Gilbert again, in hybrid installations, is electric backup favoured over gas?
Electric backup in terms of immersion heaters might be the only way to do your hot water. Electric backup generally very expensive, gas backup cheap. That's the only comment I'd say, really. So if you've already got gas boilers in and you want to keep them, I'd say don't replace them with electric, because gas is 3p a kilowatt hour, electric is around 15p a kilowatt hour. So an electric backup is only 100% efficient. So I wouldn't, apart from immersion heaters, they're the only reason I'd go electric.
Bean would like to, thanks Laura, sorry. Bean would like to just comment on, so the question from Nick Remington was, can he talk to me afterwards? More than happy to. We'd welcome our view on district heat networks and the challenges with the GLA, the Greater London Authority. So Bean is an expert on this. So Bean, can we get your camera enabled and your mic? Charlotte, super.
Yeah, I'm not sure about expert. That's very generous of you, Chris. But Nick, I think it's interesting that you specifically mentioned the GLA there, because we are currently engaged with the GLA on a view that they hold that says that ambient loop networks are incompatible with high temperature networks. And in their hierarchy for deployment, they are minded to refuse consent for ambient loop networks where they see under local planning potential for high temperature networks. We're trying to dislodge them from this view, which we believe, of course, is technically incorrect. It's perfectly possible to integrate. So if you were to put down an ambient loop system now, it would be possible to integrate it into a future high temperature network. And that appears to be the problem. And I think your note says you seem to be hitting the same problem there. I'd be very happy to talk to you about who it is you're talking to, so that we can perhaps join some dots that one and try and tackle that one off. We've been discussing it with SIPSI. They agree with us, but someone at the GLA has clearly got a problem. I think I know who it is. So perhaps we can take this one offline, Nick.
Super, Bain, thank you very much indeed. I've given Nick my email address as well, so if there's any supplementary questions on ambient networks, then we will be more than happy to help. Right, I've just scanned through the questions there. I don't think there is anything else. So anybody else got any last points to make? I guess that means all that remains is to say thank you very much to our new chair, Laura, for a really illuminating webinar and fantastic bit of myth busting, which is one of my favourite topics in ground source particularly. So thank you very much indeed. Laura, what's up next week? Nothing?
So next week is half term, but the week after, I believe we have Tim Baker from BA Hydro talking about regulations that we don't know about. Cool. Which is going to be a lot more interesting probably than I've made it sound. She's going to be a good speaker. So 2 weeks time, back here 1 o'clock, and we'll be launching the new programme very soon, hopefully next week or early the week after.
Thank you very much indeed, Laura. And thank you very much to those attending.
Thanks for doing that, Chris. See you later.